we have another fantastic box. You probably want to see what's in it. This is my new addition to the bench. It is the how do you say this? Wanptek or was it Wanptek? EPS3210. It is a 32 volt 10 amp capable bench supply. I guess we'll find out. Nice and cheap. Cheaper than you can buy in this country for what it is. There's just no contest. I would shop local if I could. Can't do much when there's not much on offer. Anywho, let's crack into it. All the required foam protection. What have we got for a plug? They gave us the New Zealand plug. Excellent. I don't think there was an option for that. Or was there? I can't remember. But if there wasn't, well done them for noticing where they were sending it to. We have an upside down smiley face. And we get a book. Because we all need to, there you go, scan the QR code and follow the official website and yada yada if you need the book. The silhouette looks nice. Hope the rest of it looks even better. And we get a leads. We get a leads. Leads are, there we are, terminals to screw in and a couple of croc clips. So yeah, I've been thinking about how I can improve my fly lead setup, to be honest. They kind of get in the way of things sometimes. That looks like the front, that looks like the back end. On the back we have a fan and a hole. I wonder if they were planning on putting an on-off switch there, or a fuse, or something else. Standard IC connector. And on the front side we have our machine. Now that center terminal is green. It kind of looks cyan in that color, but that's fine. We got our selector knobs, we got buttons, memory settings. There's our power switch. So wasn't the hole on the back. And we have a screen protector. I thought this was actually going to be physically a bit bigger, but that's cool. We can do the business and be small. We're not here to judge. Before we get too carried away, we should probably do what all good men should do, and that is read the manual. Read. Right, let's plug it in. That's a tight, really tight fit. Oh, wow, I'm getting weak. The switch is off, I'll plug it in. Now before we go any further, we absolutely must do this. That's cool. Wonder what that all means. Now we can turn our output on and off, and overcurrent protection on or off. When you turn the output on, it gives you the measured value. I think that flicked there because it may have been charging an output capacitor. Right, what do we do here? Let's see how intuitive this is. We've got voltage on the top, current on the bottom, and then we have memory set. Are they set already? 32, 30, 29. So if we turn the knob, you can't go any higher because it's 32 volts. You can go down. Alright, now can we change the other values as a push button? There you go. Push again, we should get our tens digit, and we're at 0. Push it again, and we have, look at that, millivolts. So we can go down to 10 millivolts in 10 millivolt increments. There's 100 millivolts. Now I think my bench isn't very straight, it's wobbling. That's better. 10.2, okay, I'll let you go a little bit over the 10 amps it's rated at. Well, that's cool. We can change that in much the same value. Oh, 10, 9. Wait, I don't want to change that. Oh yeah, there we go. So the current works a bit differently, whereas, well, that makes sense because you can't go to 11, you know, you can't go over 10, so why would you want to change the 10th digit? But it does give you 1 milliamp, 10 milliamps, 100 milliamps, and we can turn our output on, and that should allow for, what's that, 3 volts at 1 amp. That's what I said. Over current protection, we have USB power options there. I wonder if it does, it must do USB-C, it must be able to support up to 20 volts. Well, I may have thrown the book away a little too soon, but you'd never guess how to do this. So if you press and hold the output button for, was it 5 seconds? Yep. You can change some of these things like native ID. So it can be connected to a network, but I think that function may have been left out, and that's probably the hole on the back that would have been some kind of socket, maybe serial data socket. Then there's parameters for the output default state, so if you turn it on, is the output on or is it off by default? There's brightness for the screen, there's buzzer, mute, there's baud rate for the comms mentioned before, and communication size setting, small structure or large end structure. Okay. Can be equipped with a USB communications module. Okay, USB communication module, interesting. Alright, well, we won't worry about that. Now this is supporting fast charge on USB-C, which means it should be able to do up to 20 volts. And I have a question. Is that separately built in, or is it using the same switching supply? Because if that's charging at 20 volts, can you actually provide 32 volts out the jacks on the front? Let's do some tests on this thing. I need some wires attached. Our banana jacks. And we can have a look on the scope and just sort of see if it's got a nice clean output or not under load. Shall we start with the dummy load? Okay, let's turn our output on. And we have, that says 3 volts. Can I adjust it while it's on? I can. 3.1, 3.2, 3.3, 3.4. So I don't know. I should put my multimeter in line with that so we can see something a bit more accurate perhaps. Nothing's gonna move and touch each other. 3.48 volts according to that, which has to be a bit more accurate surely. So if we go 3 volts, we're at 2.982, and then we've got 4, 5, 6. Let's go back to, let's go to 5, shall we? And we should be able to pull 1 amp from this according to the setting. So we will start with the course adjustment. Oh, right off the bat, 1 amp. I want to get that. Okay, 300 milliamps. That says 330. There you go, half an amp. $800 milliamps. 900 milliamps. And we're saying, what do we got for our voltage there? Why is that all over the place? Because I've hit 1 amp, that's why. Whoops. Back that down. So obviously it's sensing current right up the front but not down at the load, so our voltage is going to be a little bit different after a bit of drop across the lines. How close can I get to current limit? That's almost there, and then if I go slightly more, how much over can I go before it limits? Right there, it's hit current limit right there. So what does turning on OCP do? What does OCP do to it when I get up over current protection? It turns it off. And if I dial the load back down, it doesn't recover. So that's handy. You got to push the output button to come back. There's our output. 5. There we go. So let's crank this thing right up, shall we? There's 20 volts, and actually no, I'll start at 5. I'll do 5 volts, and I'll do 10 amps. That's 50 watts. This thing can do 50 watts. I think it do 150 watts. And our output is on, so here we go. 2 amps. 3 amps. Let's go up to 5 amps. So that's on 5 amps. Let's carry on. 6 amps, 7 amps, 8 amps, 9 amps. There we go. Now turn off OCP because we don't want it to die on us. Oh, it's handling 5 volts at 10 amps quite nicely. And it just current limited because this thing isn't perfect. I will turn that down. I can smell a bit of heat coming off that. Okay, let's try the scope on it and see how it looks when we're getting under load like that. 1 volt per division. And if we try and single shot capture the output coming on, let's turn it on. So it goes in a couple of steps. It shoots up to 3 volts and then there's a bit of a curve before it hits its threshold there that we've set it at. So interesting. I wonder if it does that for all levels. Go for 10 volts. Click. There we go. And that's done the same thing. It's jumped up to 6 volts. So that's interesting. So it must be a percentage of what you set it to that it jumps up to first, perhaps. So let's try, let's do our 30 volts. We'll try that again. Right, so there you can see that again it jumps up to 5, 10, 15, 15, 16, 17 odd volts. And then there's a slow curve up to full regulation, which is good. There's no overshoot on that. So I think we can trust this not to spike our loads if we have any sensitive things hooked up to it. Let's just do 1 volt out of curiosity. I just want to see what 1 volt does. And go. Well, obviously not as far to jump up to start with, but there is a little one just down there. It jumps up to just over 200 millivolts, and then there we go. Okay, let's see how this thing will regulate under load. AC couple, because we don't want any offset while we're looking at the low levels of regulation. Let's turn on our output, and I will increase our current there. Nope, let's turn on our output. Now the output's on, and I will increase our load on that. So there's 1 amp, 1 volt at 1 amp. Should probably make that more than 1 volt. Let's go up to 5, and I have got the current set for 10 amps. So there's 5 volts. I'm just winding up the wick and we'll keep an eye on it. There's 5 amps there. Looking pretty smooth. 6, 7, 8, 9, and 10. So I need to come back down a bit. There we are. 5 volts at 10 amps, and it's looking pretty good. So I'll come back down and we'll try a higher voltage. 6, 7, 8, 9, 10. So there's 20 volts. Now I can only go up to 150 watts or 180 watts, I think it was. So there's 100 watts. That's 20 volts at 5 amps. And at 100 watts, that's pretty smooth. There's really not a lot of noise on there at all. If we go to 100 millivolts per division, it's barely 50 millivolts peak to peak. There we go. Go up to 50 millivolts, there it is. It's not even 50 millivolts peak to peak. There's a few spikes in there, of course, but on average, it's yeah, it's pretty good. Come down to 10 volts, and I'll just turn off the output. So let's see what it behaves like if we turn on into full 10 amp load. Actually, I'll be a bit nicer to it. We'll go to a 5 amp load. So we'll come on straight into a 5 amp load, and I will turn on the output now. We're 10 volts, 5 amp current limit. I need to back my load off a little, it kind of overloaded it. Let's go down to 4.7. The power supply went into current limit. Oh yeah, so that jumped into 4.7 amps. Alright. I suppose I should take it off the 5 amp current limit if I'm going to set a 5 amp load. Might as well just go up to, we'll go 10 amps and then we'll go turn that on. Not a lot of noise during startup regulation, which is good. So what happens if, let's go back and do what we did at the start. So 1 volt per, we'll go 2 volts per division. And start again, shall we? And on. Oh yeah. That seemed to go off without a hitch. And it still does the little jump up. And then some regulation control, so that's pretty good, isn't it? We'll set it up for 10 volts at 9 amps. Really not noticing the fan in this thing. It's either that or it's not hot enough to need it. Okay, 10 volts into 9 amps. Here we go. There, no overshoot there. It gets up there and does the business. Not that I'm going to be treating it like this. That's good to know it can do it. Okay, now the fan just kicked in the power supply. That's quite noisy. Honestly, I thought it would have happened sooner. Maybe be load based. Now it's off. That's fine. I was sure it was running earlier, just a bit slower. Oh, that seems like it's going to do the job. I quite like that. It's going to be a lot nicer than my old supply, which is perfectly good. It's a transformer based supply, linear supply I should say. This is a switching supply, so it's good to see that there's very little noise on that. I need to find something that I can charge off USB-C that won't matter if it blows up. I'm not putting my phone on there. I don't think I have anything. Next time I have something, yeah, I haven't got anything right away. Okay, well, let's see how these memory settings work. I guess it's like anything else. You must just hold it down to set it right. So let's do one at, I guess we'll do one at 1 volt, 3 amps. 3 amps, that could be our short detection voltage, yeah? There we go, set. So if I go back, 1 volt, 3 amps, how about that? The next common voltage I use is, if I replace this for my microscope ring light, then what I do there is I have, it's about 12 volts, but I current limit it to 270 milliamps for maximum brightness and minimal burned out LEDs. It's better than the setup I had. I actually cooked the original current controller in the ring light, so I bypassed it and I just power it myself. I used to always get in the trap of leaving the current wound right up while I was doing something else at 12 volts and forgetting to wind the current back down. But at least this way I can go, okay, well, I want to do something else, whatever, and then when I plug the ring light back in, then I can just hit that and it'll run off that. That's the little things. I need to fix that ring light because I have actually burned out a couple of LEDs too. Oh well, this is the fun we have. And I've got a spare ring light that I could probably steal LEDs from because this one has more in it than the other one anyway. You probably all want to have a look inside it, don't you? Oh, all right. So each side has 3 machine screws and 1 plastic screw. And then I'm guessing it will just pop off, yeah? Like that. That's quite the basic power supply. What was I thinking of? I don't know why I was thinking of something a little more. Anyway, that's what you get for something that can pump out 32 volts at 10 amps, 320 watts. Now, we have for construction, we have our mains input there. We have a voltage selector switch on the back. Okay, I probably should have paid more attention to that and made sure it was set at 230. We have an earth lead that goes to the goes down to the PCB there and is soldered onto the PCB, and then there is a post soldered to the PCB that is then screwed to the chassis down in the bottom there. I'm not seeing any signs of the paint being removed from the chassis to make a good connection. And we have the front ground post is also soldered to the board on the same, well, that's actually isolated with a capacitor there. It's not a trace, there's not a trace between. Nope, there is a track between the two on this side of the PCB. So at least the binding post on the front is connected to mains earth directly, but not necessarily the chassis because of that paint. There's a current sense resistor there. We have high quality caps. And what brand are those? Chong X. Whoa. Chonks. Let's hope they don't become chonky caps and swell up. We'll keep an eye on that. But as you saw, our regulation was really good. We have, that's our main switching supply there. Looks like there might be another one down there. Oh, there, that blue one there, that'll be our probably 5 volt line for running the processor. Our input capacitors are Ching branded. And same, what have we got down the bottom? Okay, it looks like all the green ones are Chonks and the black ones are Ching. Let's hope they're nice low ESR ones. Not a lot else going on in there really. A little green transformer down there, I'm not sure what that's doing. And under the heatsink we have probably our main switching MOSFETs, which will be surface mount by the look of it. Oh, actually it looks like you can barely see. It looks like a TO230 package. Yeah, that's what it looks like. One large and a couple of smaller ones on the input side. Okay, so that must be, yeah, that will be a diode pack for rectification under there, especially if it can pump out that sort of current. For a front panel we've got one IC down in there, TM1629C. I wonder where they would attach the serial. Oh yeah, there we go. So in the bottom right we've got what's that, voltage, ground, transmit and receive. There's 4 lines there. And whether they go up to anything that's populated and currently working, I don't know. And there's another header up the top as well, and that's got RGSV there. We have another little chip over here in the corner, which is, it says T128M on it. Is that a 128K EEPROM? And then there's not much else going on there. I'm not going to rip the whole front panel off, but there's clearly our 7-segment displays running down through there, so there's not going to be anything special on the front side other than knobs and buttons. So that's a look at the Wanptek 32 volt 10 amp capable power supply. It'd be interesting to get the 5 amp version and just see what it's like inside. Is it different, or is it just a software upgrade that you're paying for? I guess time will tell how well this lives up to whatever I throw at it. I'm not normally hard on power supplies anyway. I just wanted something with much nicer controls, because my old one has potentiometers and you've just got to sit there and just keep tweaking it a little bit and a little bit more, and if it's a noisy pot because it's a little bit dirty, then you know you've got to mess about with it to try and get as precise as you want. But hey, whatever. Maybe this could have been zip tied somewhere. It's flapping about, and literally in the breeze because the fan's going to be blowing it around. I could zip tie that and somewhere. Oh, I did notice the heat shrink's fallen off on our main switch there, but it does seem to be fairly well soldered on. I hope you like that look at the Wanptek programmable DC power supply. And if you're looking for a nice cheap power supply that'll do the job, this looks like it's probably going to do the job. If you're doing any sensitive work, building circuits and whatnot that were had very unique requirements, you might want something that is a little bit more reliable perhaps. But this is all right. It's got overcurrent protection. It seems to function adequately. How much did I pay for this? Let me have a look. I can't remember. On sale. It was always on sale. $160 delivered. Not bad for $160. You can't get much from local vendors for that. And you will see it in future videos. So let me know if you like that. Let me know your thoughts, and I'll catch you all in the next one. So a little bonus footage. I wanted to see when the fan would kick in. So I left the lid off and hooked up the load again. It hasn't come on yet, and I turned the thing off for now. But that inductor right at the top there, that's on our output. All the power goes through that inductor into the capacitors above it, and that's sitting at like 50 degrees. Like, I mean, I can touch it, but it's pretty warm. Like I think the core of it mainly is what's gotten hot. I don't know if that's going to last. So let's turn the output on. It's 10 volts into 10 amps. It's gonna dump right away, and let's just see what happens. And it's it's currently 98 watts. 10 volts into 9.8 amps is what it's sitting at, and our inductor is quite warm. It's now 50 degrees and going up. I don't know if I like that. I don't know if I like that much at all. Could you imagine if we were at 30 volts? If we were trying to push that sort of power out there? I don't think so. Not to mention all of that heat is going up into those capacitors. Like, that's kind of poor design. Everybody knows you shouldn't put heat into capacitors. We're at 60 degrees. Let me run that for a bit and we'll see if the fan comes on. Okay, that's up to 84 degrees and the fan just kicked in now. Just kicked in now. So we've got some airflow. It's screaming fast. I don't know. It must be monitoring the temperature of the output heatsink, because it just turned off again, and it didn't drop the temperature of the core at all. The heatsink beside it is, what's that sitting at? Can I get a it's a lot less, put it that way. That inductor, woohoo, 80 degrees. I'll be burning the enameling off the windings soon. Now, I'm never going to run it this hot, but it's interesting to see how this thing functions. Now, the little hot little circle down in the bottom there, you can see down in there, that's a little input MOV. Now the fan just came on again. We're at 93 degrees on the little inductor. If I just put my hand there to create a bit of a airflow over it, that doesn't run for very long. I'm inclined to modify this and, you know, let the fan run all the time. But that's just sitting there and baking. Now maybe with the lid on it might you know, might get warmer quicker and the fan might stay on longer, but I don't know. I don't think the thermal efficiencies of this unit are that great. I'm just going to turn it off so the dummy load's still cooling down. That's what you can hear. But that's holding the heat in that core, 93 degrees. Let's see what I can, what's the maximum I can push this up to. 30 volts. Okay, here we go. 15 volts at 10 amps is going to be pushing the limits of my dummy load. Let's see if we can get there. Okay, close enough. We're 14.7, 147 watts. How hot is this thing going to get? We've only dropped about 10 degrees while I was doing that, but we're up at 91 again, just with some passive airflow. There's maybe a little breeze off my dummy load, but that's not going to have any effect on anything. 96. Can we hit 100 degrees? Surely the heat would be radiating. I want to say, oh yep, there we go. It's kicked in. We're at 99 degrees on the core. Now over here on the heatsink on the end here, there's some white paste going down to something marked RT1. I think that's where our temperature is being monitored. Should be, I would have thought, up against the heatsink, but it's just on the PCB. It might be on the heatsink. It's hard to say what device that is. It's covered in white goop. But anyway, we're at 105 degrees. 105 degrees. Oh, the poor little thing. Yep, the fan just cycled again. So it cycles. I would like to see it cycling more frequently, or at least staying on. Just turn it on when you're at a given current. Don't wait for it to get hot. I know they're probably hoping to please people for keeping the thing quiet, but anyway, let's turn the output off there, and that just holds the heat. Holy moly. I wonder if you can get a more efficient inductor, but yeah, I don't much like that at all. Capacitors are they're warm, but yeah, they wouldn't last long if it was like that all the time. Alright, well, at least I'm never going to be holding that sort of load for extended periods. Anyway, bonus footage.